which consists of Aisha, Weekend, as well as Andrea, we will do experiment 3, which is iron selective electrode for N iron toxicity. So basically the objective is to determine the concentration of chloride and nitrate in water. So basically in this experiment, what we need is deionized water, sodium chloride, as well as calcium nitrate. So basically in this experiment 3, there are 4 assignments to be done. So the first assignment is basically calculation and preparation of Cl- and O3- stock solution. So basically what you need is sodium chloride as well as calcium nitrate, followed by spatula and weighing board. So basically how much of the mass should you measure? So basically how we are going to calculate is basically from the formula of molarity equals to moles over volume. So you know that 0.1 is actually the concentration, and hence from here we can actually derive to the mass that we are supposed to measure. So here Andrea. So Andrea is here with me today, and she will help me to measure the correct amount of sodium chloride. So before you proceed, please ensure that the weighing balance is stirred and sweep any residues left at the top of the pan here. And the amount that we're going to measure today is 1.46 grams. So after measuring sodium chloride here, please label the weighing board to avoid any confusion, and do so for every measurement that you are doing. So next, we are going to proceed with calcium nitrate. So the amount that we are measuring today is 2.95 grams. After doing the calculation, please ensure that the weighing board is labeled too. In assignment 1 also, after measuring calcium nitrate and sodium chloride, what you need next is basically deionized water, 2 volumetric flasks which is 250 ml each, a pipette, a beaker, as well as 2 caps for the volumetric flask. So firstly, add all the solutes into the volumetric flask carefully. Ensure that everything is inserted into the volumetric flask. So as you can see here, fill up the volumetric flask with deionized water until it reaches the mark here. Ensure that all solutes are not stuck at the neck of it, and wash it with deionized water. Next, after filling with half of the amount of deionized water, cap it and shake it the way as how it is, and ensure all solutes are dissolved. So here is the maximum amount of deionized water that you should fill in with, and before reaching the mark here, use a pipette and top up slowly to ensure it doesn't exceed, as when you exceed the amount that you should be filling in with, it may lead to inaccuracy of results. So basically, we're going to prepare for assignment 2 and 3. So assignment 2 is preparation of 10 to the power negative 2 molarity, as well as assignment 3, preparation of 10 to the power negative 3, 4, and 5 standard solutions. So basically, it's in assignment 1. So previously in assignment 1, we have actually diluted calcium nitrate and sodium chloride into the 250 ml volumetric flask, which is 10 to the negative 1 molarity of dilution. So in assignment 2, you need 2 volumetric flasks, which is 200 ml for dilution of 10 to the negative 2 for both calcium nitrate and sodium chloride. So basically in assignment 3, we need a 6 volumetric flask, which is 3 for calcium nitrate and 3 for sodium chloride. So basically we're going to dilution factor of 10 to the negative 3, negative 4, negative 5 for both sodium chloride and calcium nitrate. And please do not forget your deionized water. So assignment 2, preparation of 10 to the negative 2 molarity of the solution. So basically we need a pipette of 20 ml, because we're going to pipette the nitrate solution to here. Why is it 20 ml? It's because due to here. Because of the formula of M1V1 equals to M2V2, and as you guys can see here, it derived into 20 ml. Okay. So now we're going to pipette 20 ml of solutions from 10 to the power negative 1 to 10 to the power negative 2 of calcium nitrate into the volumetric flask of 10 to the power negative 2. Please transfer your solution into the beaker before pipetting them, as this will avoid any contaminations to occur. Andrea is here with me today, and she's going to pipette 20 ml of calcium nitrate from 10 to the power negative 1 to 10 to the power negative 2. Please do so for your sodium chloride with the amount of 20 ml. So in assignment 3 is the preparation of 10 to the power negative 3, negative 4 and negative 5 solution from a 10 to the power negative 2 stock solution for both sodium chloride and calcium nitrates. So basically what you need is 10 ml of pipette as well as 2 ml pipette 2. So as you can see here, basically for 10 to the power negative 3, please pipette out 0.1 ml, as well as for 10 to the power negative 4 is 1 ml, and 10 to the power negative 5 for 10 ml from your 10 to the power negative 2 stock solution. Please do so for both sodium chloride as well as calcium nitrate.
Yeah.
Okay. So basically for assignment 4 is measurement using iron selective electrode. So basically you need this TISB for chloride test, which is the ionic strength of 1 ml. Also that from, remember the 10 to the power negative 5 chlorine that you have previously pipetted inside here and dilute. So basically what you need is you need a 50 ml pipette and pipette it into this little cube beaker. So after you have done so, pipette 1 ml of the ionic strength adjuster and also mix them together. Okay? So do the same thing as what you did for 10 to the power negative 5 molarity. So basically repeat with 10 to the power negative 4, negative 3, pipette 50 ml each individually and 1 ml of the strength adjuster into the cute little beaker of chloride test. So please ensure that the ionic strength adjuster is only for chloride test, as you can see from the bottle here. So basically in assignment 4 we'll be using iron selective electrode. So basically this machine will be measuring your pH, and over here is your electrode. You'll be using chloride electrode for your sodium chloride, and for your calcium nitrate please use a nitrate electrode. So basically before you start merging it with other solutions, please use Kim wipes and wipe the electrode carefully and place the magnetic stirrer magnet into the beaker for 10 to the power negative 5, negative 4 and negative 3. After you have done so, place your beaker on the middle of the magnetic stirrer, submerge the electrode into your chloride test 10 to the power negative 5 beaker. Please repeat the same procedure for negative 4, negative 3 for chloride and nitrate test. Switch on your magnetic stirrer and everything will be well mixed, and your pH machine will be stabilized, and from there you can take your readings from the machine.
Measure 50 ml of sample A into a small beaker of chloride test.
The last experiment, okay, I would like to tell you, okay, track your
And then pipette 1 ml of
and your individual data sheet and your
for chloride test.
Okay, for me,
Do the same for sample A, B, C, D, and unknown sample.